Hello, ladies and gentlemen. Welcome back. We're going to continue our little discussion on energy. And last time we talked about energy coming from the sun as part of the electromagnetic spectrum. The sun really gives off three major parts or three components of the electromagnetic spectrum. Visible light being probably the most important, a little bit of UV, and some infrared radiation. That radiation comes to us much like we see here. We look outside and we can see the sun and we can see the visible light coming in. UV we can't see, and the same with the infrared we can't see, but we get little scenes like this. Or when we're looking out from space towards the Earth and the sun, we get to see this. That radiation coming in from the sun is known as insolation, incoming solar radiation. Okay, so we put these three parts, the three beginning parts of each of these words, to get insolation. It's a term that we're going to be using quite a bit, definitely with over the next unit or two. So insolation is nothing more, and that's insolation, is nothing more than the energy coming in from the sun. The sun's energy, and so we have the sun. It can come straight down or at various angles to the Earth's surface. Okay, factors affecting insolation. One of the biggest ones is going to be angle. Okay, the angle at which the sun's energy is coming in is going to have a huge impact on how much energy we receive per unit area. The sun, if the angle, so here's our sun right here, happy sun, and here's the ground. If the sun is directly overhead, the sun's energy comes straight down, and it forms a 90-degree or right angle right here. That is when the sun has the greatest intensity, or the energy has the greatest intensity on Earth's surface. At noon, we would expect to see the sun to be close to overhead or at a 90-degree angle with the ground, depending on your location on Earth. So this would be noon. At sunrise or sunset, the sun is barely peeking up over the ground. Here's our sun. It's just coming up over the horizon, and the sun's rays come in like this. Notice that the angle here is pretty small. So this would be sunrise or sunset. Either way, the angle at which the sun's rays come and hit the Earth's surface is a very low angle. Low angle, that means we're going to have lower intensity of radiation and lower temperatures. Another big one is our duration. How long the sun's out, basically. The longer the sun's out, you would expect it to warm up more. So angle of insolation, duration of insolation, those are going to be two biggest things that affect the insolation coming into Earth, and will definitely change depending on our latitude, season, day, night. There's a lot of things that can change our angle and duration. Okay, so what happens? That sun's energy comes in. We want to know, first off, how does the sun's energy come in towards Earth? What happens when it strikes a surface? And then how does that heat transfer throughout the different spheres of the Earth? There's three major ways that energy transfers, and that's through conduction, convection, and radiation. Okay. This little diagram here shows us the three different ways that energy can transfer. So this is three ways energy can transfer. Okay, so we have through one right here is conduction. And here in this little spot, we can see the person holding on to this pot. This is, you can see that the pot is over one of the burners, or one of the electrical elements of the oven. And the heat transfer is going to go from here through the metal pot and into this person's hands. Ouch. Okay, so that is one. Okay, and most of us have seen this from day to day. So conduction is a transfer of heat through solids, through direct contact. Okay, so touching a hot stove, if you're walking on a driveway during the summer, like a blacktop driveway, and your feet walk into it, it gets pretty hot. Same thing, sand. During the summer, you walk onto sand, you can feel that heat coming into the soles of your feet. So conduction is through direct contact with a source of energy. Okay, metals are good conductors of heat, as long as there's a lot of other things. There are things that are not good conductors of heat also. Okay, heat will pass along this rod. Okay, so we have a little metal rod being held in this candle flame. So the heat energy is being concentrated here, and it makes its way through and into this person's hand, where they'll eventually feel it. This is through conduction. Like I said, metals are very good conductors of heat. Things like air, poor conductor of heat. Also like things, ceramics, porcelains, things like that are also poor conductors of heat. So there are many things that are good. Wood is also another poor conductor. So good conductor. Conductor. Metals are very good. Poor conductors. Things like wood, air, water is also a poor conductor of heat. Those things are poor, so it's just the good and the bad when we get to this. Okay. We also have convection is our second mode. So this is number 2, second mode of heat transfer, and probably one of the most important ones that we'll be spending a huge amount of time with, not only in meteorology and climate, but also when we get into the layers of the Earth. Really, this keeps going. This is pretty important. Convection is the transfer of heat through fluids, liquids, and gases. Both act as fluids. Okay, so water is a fluid. Air also acts as a fluid. Results from differences in densities within those fluids. So what happens is warm fluids have a low density. Cool fluids have a high density. Okay, so the differences in the temperatures of these cause differences in density and results in movements. These movements create convection cells. We can see this with warm air rising, cool air sinking. And you'll see with the diagram coming up how these convection cells work. So over here we have a little fire right here. In our little fireplace, wood burning stove, doesn't make a difference, but it heats up the air around it. So the air heats up. When the air heats up, it rises. This is hot air, which has a low density. The low density causes it to rise. It hits the ceiling of the room, and it makes its way over. And eventually, by the time it gets over here, when it's really, really, really far away from the source, we have the air cools, becomes more dense, and sinks. Okay? More dense, it's going to sink. Less dense, it rises, and eventually makes its way back, and the fire heats it up. It becomes low density again and rises to the surface. We need to remember that high density, increased density, is going to cause falling air or falling fluid. The exact opposite holds true. Okay, if we decrease density, that's going to cause rising air. You need to get these straight, memorize them, watch this 1,000 times. Do whatever you have to do to make sure that you get this. This keeps popping up over and over again. Okay, we can see another example of a convection cell right here. Okay, we have our warm air rising. Okay, why? Because it's less dense than the fluid around it or the air around it, and eventually it's going to sink as it cools down and creates a convection cell. Okay, moving through, we have a convection cell on the lid wherever that heat source is. So right here, let's do a little green. So right here is our heat source. Well, the heat source is there. This fluid becomes less dense, rises up, and creates convection cells here. If we were to move the heat source over, the area where the warming water would be would change, and it would cause a little bit different cell. Same thing, here's a cell here. Notice we have two loops forming, and this is where our heat source is right there. Okay, just another example of a convection cell. This one a little bit more crude, but since the sun is directly overhead in this location, it forms a 90-degree angle. Well, we know that there's a higher intensity of energy there, so this warms, becomes less dense, and rises. Over here, okay, we have a lower angle. This angle right here is low angle. So this is going to be cooler, and eventually, since it's cool over here, the air is going to sink, and what we get is another convection cell. Okay, we can use this theory of convection to basically cause hot air balloons to fill up, not only to fill up, but to become less dense and actually float through our atmosphere. Here's just another picture of a hot air balloon. Okay, notice that basically it's floating in this liquid around it, so it's floating in the air, which is more dense. So this is less dense, and over here is more dense. So it causes the balloon to go up and eventually to move in whatever direction it might be going. Okay, the last way we have the last method of heat transfer is through radiation. Okay, radiation is the transfer of heat through space, and the best example of that is sun's radiation reaching Earth. There's no medium, there's no air in space, so you can't have conduction or direct contact of a molecule hitting into another molecule and hitting into another. There's no fluids, air, or water or liquid or anything like that for there to be convection cells in space. So that transfer of heat right here is through empty space, is via radiation. Okay, and then that takes us to specific heat. Okay, we'll talk a little bit about we'll talk a little bit more about specific heat in the next little segment. So just wait around; it should be coming up soon.